Good morning, good afternoon, or good evening, and welcome to this Container Journal workshop brought to you by Techstrong, AWS, and Tetrate. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting workshop ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope you do because this is a workshop, we want you to send those questions in using either the chat if they have to do with the workshop itself, or if they're more general questions, do feel free to send those into the Q&A tab. You'll also see a couple of handouts have been uploaded under the Handouts tab, so feel free to check those out. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So the title of our workshop today is Enterprise-Grade Tetrate Istio Distribution on Amazon EKS. And I'm joined by Omar Shehab, Senior Product Manager at AWS Marketplace, Peter McAllister, Partner Engineer at Tetrate, and Saptak Sin, VP of Alliance and Partner Integration at Tetrate. So thank you all three for joining me, but Saptak, would you like to get us started on this workshop?
Thank you so much, Cody. Now, in today's workshop, first of all, I'll just to walk through the agenda, I'll give a quick overview of who we are at Tetrate, a little bit about ServiceMesh Istio and how it fits into your application modernization journey. And also, Omar is going to dive deeper into how AWS Marketplace is making Istio deployment much easier. And then we are going to get into the meat of it, and that will be led by Peter in terms of the hands-on workshop part of it. Now, Peter is going to walk through it so you can follow along, but also we'll be providing the instructions so you can also look at it and follow the instructions at your leisure later on. So with that, let me get started. So a little bit about ourselves. We are a group of technologists primarily. For example, our founder, Varun Talwar, he is the creator of gRPC and the co-creator of Istio. Before he found Tetrate, JJ, who worked at Twitter, and some of the very, very early works on Envoy came from Twitter, actually, before Lyft picked it up and ran with it. Zach is part of the Istio steering committee. Lizan is a senior maintainer at Envoy. Sheng, who's the creator of a complete observability platform called Skywalking. It's actually pretty very popular open source observability platform. And Adrian Cole is a maintainer of OpenZipkin. But apart from that, we also work with some of the security standards body, like NIST. So NIST is a government body which comes up with various standards, as the name suggests. And we actually jointly co-authored some of the security standards that many of the government agencies adopt. Here are 3 examples of those. Not just that, many financial services companies or other security sensitive industries adopt these security standards. Our folks like Zach has also co-authored some of the books on Istio and so on. So bottom line is that we are very, very involved in the Istio community. We are one of the, depending on what time you check, one of the top 3 contributors to Istio and or Envoy. And we are also working very closely with the rest of the community, rest of the industries, to make sure Istio gets adopted as widely as possible. So with that, let me dive into a little bit about what is a service mesh. A service mesh basically provides you a bunch of benefits. The benefits are, first and foremost, is around being able to um, uh, um, enforce encryption in transit and to establish application identity. What it means is that when a service wants to communicate with another service, you want to make sure that that service has an identity which can be validated and authorized to enable that communication. Um, Secondly, things around resiliency, right? So when, for example, a particular service is on a particular cluster, and say for whatever reason the response time is becoming worse and worse, the queues are getting longer and longer, or that particular service endpoint is not at all reachable, then you need to be able to transparently switch to another instance of that service running somewhere else. So this kind of load balancing and resiliency mechanisms can be implemented very simply. Thirdly, things like observability, like you should be able to look at the various metrics, logs, traces, in terms of not just troubleshooting, but um, uh, m- uh, but maintaining the SLAs around your services. Now the question is, how does it do that? Now, there are two parts to it. One is what we call the Envoy proxy. The Envoy proxy is a sidecar today, which sits with every pod that gets deployed. And then we have the Istio control plane. How I typically like to explain this with an analogy. Think of it as a home security system. In a home security system, there are two parts to it. Uh, first, the first important part is that there needs to be a sensor at every ingress and egress point. Say you have doors, windows, whatnot. And for each of those points that you want to control, there needs to be a sensor which can, first of all, monitor it. Secondly, it can probably also do things like lock and unlock based on policies, right? That those egress ingress points. So that is exactly what the Envoy proxy does. And the second part of the home security system is the so-called the brain, which is the control plane, which programs these proxies, right? So typically you'd have some kind of a device which kind of sends out the configuration to this proxies, which will then use that configuration to behave the way they do. So that's kind of how I think of it. Um, so let's say if you have a security system like this, and if somebody is trying to get in through a door, you first of all needs, if that person or thing, whatever, doesn't, the identity of it doesn't match, say your what you want to allow, then the uh, sensor or the proxy can then say, hey, it doesn't, you're not authorized, so I'm not going to let you in. Or it can also have logic like, okay, at this points during the day, I'll let you in. At other times during the day, I will not let you in. Or it can even be much more sophisticated in redirecting traffic. Let's say if you have a weird maze of hallways and you want to divert traffic in a particular way, you can automatically unlock various ingress egress points to route the, literally the foot traffic in a particular way. So the Envoy proxy plays a very, very important role in all this. While any communication that happens between service A and service B is directly from one service to another, but it all gets intercepted by these proxies, and however the control plane has programmed these proxies, they enforce that. But no communication goes through the control plane as such, so that there is no kind of bottleneck created that way. So that's kind of the high level overview. So now to move to the next section, so to say, means we worked with AWS very closely to make sure that Istio becomes as simple as possible to deploy and configure for Amazon EKS. So that's what Omar is going to dive in. But before I hand off to Omar, I would like to also say that we have been a close partner with AWS, and we have been launch partners for EKS, EKS Anywhere, EKS Fargate, ECS Anywhere, Cloud Map, EKS Blueprints, and a bunch of other ones. So all this to say that we work really, really closely with the AWS team, and plan to do so going forward. So with that, Omar.
Awesome. Thanks, Septec. So, team, you guys have heard from Septec what Istio is and what ServiceMesh is. Hope you guys are as excited as I am to look at this, and as excited to try Istio. There's a lot of customers out there that have tried it and they love it. You can go to GitHub and see how many downloads they have today. But yes, as Septec said, we partnered very closely. And we've partnered very closely to make sure that you as a customer are able to get Istio from Tetrate very easily and deploy it very easily on your EKS clusters. And surely Peter will be demonstrating one of the methods, but there are many methods out there, and we'll talk about them really quickly, really briefly. But first, I did want to provide a quick plug to AWS Marketplace and provide the benefits of what AWS Marketplace will provide you. And so when you think of it, when you say, okay, well, I love Istio from Tetrate, how can I get it? And the process is not, it is straightforward, but there is a funnel that you will need to go through to eventually find that you need the software and eventually deploy it and manage it. And the process, we say it is six steps. First, you're going to have to find the software. Where should I deploy it from? We make it easy for you by providing it on the EKS console. So if you go to the EKS console today, if you go to the cluster that you want to manage, click on the add-ons tab, get more add-ons, you will be able to see Tetrate on there with their Istio solution. You're going to want to conduct a POC. So what does that mean? That means that you would want to download the solution and deploy it on a test cluster just to make sure that everything functions correctly. You're going to want to procure it. In this case, excuse me, Tetrate is free, but you still need to subscribe to it from AWS just because we're providing you the ease of management, the ease of procurement, the ease of subscription and as well as providing you a CVE free version that is on AWS Marketplace. You're going to want to validate it, deploy it, and then manage it. Perfect. And so really quick plug on AWS Marketplace. What we do is we offer a marketplace, for lack of better words, for sellers and buyers to transact. Tetrate is one of the solutions on there. But in general, we as AWS Marketplace provide you a lower TCO, accelerate the time for you to get the software that you need, and increase your customer satisfaction score by not needing to go through many different pages to get the software that you want. And there's a lot of software that we have on AWS Marketplace with a lot of pricing options. You can have free trial, BYOL, pay for software monthly, annually, private offers, whatever works for you. We also have a lot of solutions out there. In this specific case, we're talking about containers, but I just wanted to flash the slide out really quickly. And then finally, this is the most important piece, where we're not just going to provide you the software for you to deploy. We're going to send you notifications when a new version comes out. We're going to help you manage it. We're going to help you create private offers if required, as well as send over the billing through AWS billing if the solution requires bills. But back to Tetrate and Istio. And so we partnered very closely with each other to do exactly what Septec said. Provide you an easy mechanism to deploy the software on EKS clusters. Now, how do you do so is the key that we wanted to highlight here. You can go to the EKS console, click a few clicks, see Tetrate, continue with a few clicks, you can deploy it really quickly. Or you can go through CLI, and I believe Peter will be showcasing CLI. Or you can go through Terraform, or you can go through CloudFormation, or you can go through EKS Cuddle. Basically, everything is running over APIs, so however you want to deploy software, you are able to. And this provides value, and this provides power to you as a consumer to consume the software however you want, wherever you want, whenever you want. Rest assured that everything is CVE scanned and validated to launch on your EKS clusters. Some numbers out there. We're going to ensure that you're going to save up to 67% of your time finding, subscribing, deploying, and managing your software. That's a quick look from me. Thanks for this. Happy to answer questions over the chat. But over to you, Peter.
Thank you, Amar. And once again, it's a pleasure to work with you and your team. It was really productive work. So we are going to jump into workshop, hands-on part of our workshop. And here is a link. And also, I believe in Handouts, you also can access exactly the same information what I will be showing on the screens. So let me switch to my screen and we will start going through. So again, it's publicly available. You can log in, not log in, just click URL and access it. So we will go through a number of things here. So you see on the left, it's basically agenda. Prerequisites, we expecting you to be done already, but we will go through them in case you're trying it after the event. And deploying a EKS cluster, it takes about 15 minutes. So we also already deployed it. All other steps we will go through. So we will touch a little bit of what Amar mentioned on marketplace subscription, and we will show how to deploy AWS add-on. I think maybe we'll be able to show both ways through UI and through command line. And then we will jump very deeply into Istio and actually talk a little bit about a couple of scenarios, what you can do with Istio just out of the box and show you how fast you can get up to speed with Istio without spending hours and days. Depending on time, last module here is implementation of AWS NLB. It's a very common question, and we get a lot of requests and queries around it. So if we have time, depending how fast we will move, we can cover it too. If not, all information is provided there. Again, you can try it on your own. And also we have page with additional resources with links and stuff that can help you. Okay, let's start with prerequisites. So we using WSL from internet, nothing special. So it misses AWS CLI that you have to install. We will be using AWS CLI version 2. Also, you will have to create IAM role and user. So you have two things: to subscribe to TID, Tetrate Istio Distribution, which is free, but you still need to subscribe. I believe Amar already explained it. And also permissions to create EKS cluster. For creation EKS cluster, it's your decision. Maybe you have different people in your organization. Maybe someone creates cluster for you, and then you don't need to create permissions here. EKS CTL is also a tool we will be using here. There's multiple ways you can create cluster. Additional to it, how to check if AWS installed correctly, and you need also to configure your, after you created user, configure your account, normal stuff. kubectl we will need because we interacting with Kubernetes cluster, Kubernetes API. We will need to install kubectl, EKSCTL if you using, if you're installing it. Also, there's a couple things that require tarbos in this workshop, but tar is usually installed on a machine. And for every module here, we have video demonstration. Also, what I'm doing here, if you miss some part, if you need it slow, you can always access it and watch video. Moving to the next section, deploying EKS cluster. So we also prepared shell script you can download here with values you can specify. There's default values we put here. Owner name, it's something we use as a best practice, not necessary, but region is, unless you deploying in default region needs to be specified. There's a simple EKSCTL command with all these variables you specified here. And it's all you need, and in 15-20 minutes, you will have cluster deployed. So moving to next section, AWS Marketplace subscription. So let me see if I can easily, yep. I have here an incognito window just because we already subscribed. The account I'm using here already subscribed to Tetrate Istio Distribution. So there's a default one I just want to show. If we hit Tetrate here, we have actually a couple products here, but now we're concentrating on Istio Distribution. And what you will need to do, again, it's free, you will not be charged. You go to continue to subscribe and enter your account information, and then the rest, I believe I will show you screenshots. So you click continue to subscribe, and you have to accept the terms. And there's a little bit pending, around a couple minutes, when AWS backend processes your order that doesn't have any cost. And then finally, it gets a date when it's effective, and you can proceed to next step. And next step says, okay, if you want to deploy it right now, you can use AWS add-on. And I believe I can also show it. So here is a cluster we are going to deploy everything. I pre-created it, and here if we go to add-on tab, there's currently no add-ons installed. And we type Tetrate here. Put check mark and click next. Yeah, you can see here versions we support right now. And we also in references have a list of Istio versions and Kubernetes versions and show which ones are matched. So you definitely need to select version of EKS that today is supported by AWS and find matching version of Istio. Or if you're installing Istio, you need to find what versions. So there's this kind of two different references tables, and we have them in references of this workshop. So, and yeah, the rest of the steps is pretty easy. You select version and you just confirm and you click create button. But I'm not going to click create button. I'm going to go back into the cluster and show a view from a command line. And hopefully it cooperates and it will work as expected. So I'm basically was already in the next module. We talked about it, and now we're diving to the second part. And second part is deploy add-on using command line. Depending on your style and also your practices in your enterprise, you might prefer to use command line and API. So first, let's just look how it looks in AWS. So you can see there's a whole document and it explains what we've already seen, different versions of EKS supported, and just basic details around add-on. So next we will follow create add-on command that will initiate creation of. So this button, create button that I didn't press, so this single command would do it. So my cluster region. Hopefully I didn't make any mistakes. So it's right now in creating stage. And if I had to extend it to full screen. So if I refresh screen here, I should be seeing it's creating also here. So you see it's in the creating stage here. And so if I do describe instead of create, it also should show me the same information. And if we do watch on it, we will see as soon as it becomes active. So usually it takes around 1 to 2 minutes to be created. I think I've been told by AWS that it's 90 seconds. So you see it's active now. Let's change to active. Stop watch. Okay, and basically we're done here. We have Istio installed on the cluster. You can see right now Istio system namespace is created 71 seconds ago. So if we look inside of it and look at what we have inside, we will see a number of different items here. So there's a service for Istio D, and there's also CNI nodes, and there's also Istio D, kind of brain of whole ServiceMesh. And we have one deployment that running on one pod. Okay. So one thing that comes all the time is, okay, I get my Istio, but how I get traffic from outside reaching to my pods. So we don't have any applications right now in this cluster. We just have fresh add-on added. And next thing we're going to do, we're going to deploy Istio Gateway that will create three parts. It will have deployment. Deployment will initiate creation of the pod and service. And service will trigger AWS to create load balancer for us. It will be a classic load balancer. And let me bring another window here. Right now I'm looking at VPC. Let me refresh. VPC where my EKS cluster is created. And okay. And there's no, because it's brand new cluster, there is no load balancers here. So this one anymore. So after we create namespace, deployment, pod, and service, AWS will start creating a classic load balancer for me. And as soon as it's created, basically requests from outside, from internet, can reach deployment. Because we didn't configure what to do with these requests, we don't have any applications in this cluster, nothing else will happen at this moment. We will move to this part in the next module. Right now, we're just creating ingress for us. So you can see it's pretty simple YAMLs manifest. So namespace, load balancer, service. So load balancer type tells AWS to create classic load balancer. We will be listening to two ports, plain text and secure port, and deployment. So what is interesting about deployment? This deployment will not ask for any additional containers from somewhere outside. So what we deployed already, we deployed Istio with everything what it needs for proxy and for gateways. So what it will be doing here, it will be injecting Istio in this pod, and it will be using template gateway, which takes Envoy, and Envoy is a processing part of ServiceMesh, and turns it to gateway. So image auto basically uses images we already have. So other part we will create during this part, we'll create a role and a role binding. So why we need it, we will see later. So there's in Kubernetes API, there's other objects, secrets, and certificates that we can use later. And to access these objects, our deployment needs to have these permissions attached to it. Otherwise, it will not be able to read it and use it. I have already prepared YAML that creates YAML file that creates all this. So I'm not going to copy it. I'm going just to apply YAML, and we will be also watching how gateway is getting created here. Let me do that. So it's my YAML. You can download it and apply it in your environment. So only thing you need to make sure you're in Kubernetes context of your EKS cluster, no changes required inside of it. So and you can see namespace created, deployment created, service, and role and role bindings that we just talked about. So if I look at the pods here, I can see one pod with ingress gateway is listening to the traffic. And if I look at my AWS console here and refresh it, I should see, yes, I can see right now load balancer type classic running in the same VPC as a Kubernetes cluster, as a EKS cluster. So moving on.
Peter, before you move on, we have a question in the Q&A. Participant 50 was asking if both CNIs were deployed on the cluster.
So CNI is deployed on every host. So in this case, in every node of EKS cluster. Right now I have 2 nodes. Every node has a CNI running on it. I believe in AWS case, it's not necessary we can actually leverage AWS CNI. So we didn't modify this deployment too much from the standard ones. That's why you're seeing them. But yeah, so idea here is a CNI per node. So CNI per node. Hopefully it answers.
Great. Thanks.
Thank you. So let's a little bit increase complexity here. So what we're doing here, we deploying application. It's a sample application from open source Istio. It's called Hello World, and you can configure it to be to return version 1 or version 2. And idea here is a green in terminology of CI/CD is something that stable and everyone can use it, and blue is something that is new and kind of still in a testing stage before it gets full load of production loads. So what we're going to do here, we're going to say, if I'm sending additional header that says blue version equals on, it will go to namespace called blue where we're running version 2. All other traffic will go to namespace green and application version 1. So what we need to change and what we created already, we need to create 2 more objects, Istio Gateway. And Istio Gateway will say, okay, if it's port 80 and it's with FQDN name, please accept this traffic. And then we will create virtual service that says, okay, if this gateway accepts traffic and it has this FQDN, then follow this rule. So all traffic goes to green unless it has a specific header, and then it goes to different location. So again, we have shell script that will create our application, creates namespaces, do injections. So we will have Istio proxy on all ports to establish secure connection between gateway and application itself, application container. And then we will deploy application. V1 will go to green and V2 will go to blue. And finally, I believe we will deploy service. Service is the same, but service is entry point for the pod. So let's run shell script and create all these objects.
Peter, another question came in asking if we need to deploy gateway for each namespace, or should we have one gateway for all namespaces?
Thank you. It's a great question. So in this specific scenario, what we're doing right now, let me just roll up a little bit. So we're using the same ingress gateway and same load balancer, and it points to the same port. And port is in a TID ingress namespace. Application we're running is in blue and green namespace. So right now, it's a case when we're using one ingress point, one load balancer, one Istio gateway to serve traffic to multiple namespaces. Then it becomes a design decision for everyone. So if you want to save some money and run less load balancers, you can follow this model. Or if for some reasons you want complete independence between your applications running in different namespaces, you can create multiple gateways. And then it comes to management point. Do I want it to be together with my application, or I want them to be gateway namespace where I have a blue gateway and green gateway? So it's all flexibility. You can do all of these scenarios. It's flexibility that provide how to design it in terms of how your organization wants to apply it. Again, delegation of rights, permissions, right? So cost, because every separate gateway will require additional also limit of subnet IPs and VPCs. So we actually had large customers who started deploying gateways for every application, and they hit maximum number of I don't remember. I think it was maximum number of interfaces or something like that. So yeah, so you need to take it all in consideration in terms of what we're showing here. Be flexible. You can configure it the way it works for you. Thank you. Okay, so right now application is created. Blue and green application is created. And let's move to next step. Next step, we will create gateway object, and in this gateway object, I'll be saying, okay, hello world, tetrate.io. It's our application FQDN, and we'll be listening on port 80. It's all it's doing, right? So there's nothing else. Just for this specific scenario, for this workshop, and for your convenience, your environment, we are not changing public DNS. So for all our tests, what we are going to do here, we're going to put DNS name header into our call requests. So we don't require changes anywhere outside of this environment. Okay, let's apply gateway. So, and just for separation, because I know I said gateway in the last 5 minutes 100 times. So right now we're deploying gateway definition for Istio, this object here. We already have ingress gateway port, and it's two different things, right? So with this definition, what to do with traffic, with this actual binary that listens to incoming traffic. So last step in this specific module is to deploy virtual service. So the most interesting stuff of what we're discussing in this module. So again, the same host name. We check in headers. If header has blue version on, we're sending traffic to hello world blue. All other traffic is going to hello world green. And if you remember, green is version 1 and blue is version 2. You can see it here. Blue is 2 and green is 1. So let's apply virtual service. Okay. So load balancer has FQDN. It's right here, DNS name. So for command line, we will just use, we assign it to variable using Kubernetes API, because service has this DNS name known to it. So I'm using just get service command and getting, so you see it can get hostname and IP. In case of AWS, it's always hostname. But in environment, somewhere in your on-prem environment, it will get your IP. So and just to yeah, so you see it's A333B, and if I look again here, it's A33B. Yeah. So we got right load balancer. So next, let's try our application. So first, we will do a request header. And header as expected, version header 2. Now let's try it without header, and it hit version 1. And it it's pretty much showing how you can configure these objects inside of Istio and Tel Gateway, what to do with requests coming from outside on very granular level to get it working the way you want it to work. Again, just a reminder, module, it's too far, you're stuck somewhere, you always can rewatch it and follow the steps. But let's keep going, unless there's more questions.
There is one question I see.
So next thing we are going to do, sure.
Yeah, really quickly, can the Istio Gateway do HPA in case of load?
Yeah, totally. You can, I think actually I stopped following it for a while. It was automatic. So basically, when you deploy Istio, it's automatically enabled, and it can scale up to tens. Right now, with most recent iteration, maybe it got. You need to change value of Istio operator, but yeah. So it's something that's supported for a long time. Thank you. Good questions. So now we jumping to TLS, and one thing I want to mention here before we actually get to this scenario is there's a lot of different certificates and security entities in ServiceMesh, and there's a lot of confusion. So right now in this specific module, we're going to very be focused on just TLS, not mTLS, TLS. And it's the same as any not service related application, right? So it can be any application in general running on web, and you want it to be secure, you want all traffic to be validated that it's correct target, it's communication is not plain text. So right now, applications that we just covered in previous module, it's plain text, it's port 80. What we're going to do here, we're going to jump it to next level and say, okay, now I want to be enterprise compatible. I want to have HTTPS. There's whole other world of mTLS communication between services. So ServiceMesh allows you to secure communication between two services in the same namespace and different namespaces across the clusters. You don't need VPN. It's all can be encrypted via mTLS. We are not going to cover it here. I have resources listed here. You can look at it. And also, we started talking of second part of this workshop, maybe where we can look in more details in these cases. Also, in Tetrate for TID, for Tetrate Istio Distribution, it also has coverage of how you configure and use mTLS. Another thing, what we're going to do here, we're going to use here SelfSign Certificates. Let me just move back to the beginning. We're going to use here SelfSign Certificates because, again, for easiness of use, we don't need to be touching any parts outside of our environment today. But for your enterprise environment, definitely you want to use your CA. And again, in our documentation, we have whole coverage of how to leverage AWS private CA, PCA. So it's really easy configurable. Basically, you tell your environment to use to pull certificates or request AWS private CA to issue certificates for you. And they're rotated together. So it's really working together very well. In this specific case, just for simplicity, we're just using SelfSign. So what we're going to do here, request coming from internet. Now, before we were listening only to port HTTP, now we're adding HTTPS. It will hit the same gateway namespace. We will create additional object here, demo credentials, and demo credentials object, it's a secret in Kubernetes API that will have our TLS certificate. And we will modify a virtual service saying now, let's say our green application, our first version of application was really basic. It didn't have any sensitive information. If it hits port 80, go to green. New version of application, version 2, blue, has sensitive information. We only want HTTPS service to be served here, only HTTPS requests. I have it in below diagrams, but here I'm not showing because it's overloading, but I will mention it anyway. So a load balancer, AWS load balancer, classic load balancer here, it's not terminating TLS connections. It's working here as pass-through. Request comes, goes to ingress pod, and ingress pod terminates request. So three different ways we're offering you to create certificate. One, you can download a secret that are ready and just apply it, and you will have your certificate. If you want to create secret on your own, there's a command how to create it, and also you can download certificates in a tarball, untar them, and apply, and you will get basically the same object as the first one. Number 3, if you're watching sometime after now, certificates are corrupted, expired, whatever. We also included very simple bash script that will create certificates for you, brand new, fresh certificates that you can leverage. Okay. And let me switch back to my console. So yeah, I'll do just first one. I have already certificates. So secret is created. And next step, we are not listing here all YAML, we're just listing part of that we're changing here, gateway to listen to port 443, because before it was only listening to port 80, and we're saying it's HTTPS and the same host name. And also this we just created demo credentials. It's a TLS certificate. Let's do that. Okay. And now time to change virtual service. Really, we don't need to change it, but because, as I explained, we now will be sending all TLS traffic to blue version 2, and all. Let's complete this step. Okay. And here commands, I'll repeat them, but basically, if you stopped somewhere, if you finished previous module, closed your console, and now you reopened it, and your variable is unset. So here is just repeating command to get address. It's the same address as before, A33, the same load balancer. And what I will do here, I will send 5 requests. First, I will send them to port 80. Actually, it's going to be 10 requests because 5 I'm sending without header and 5 with header. And I want to confirm because I'm sending them to port 80, you see there's no HTTPS here or anything. So they all supposed to land on green. Okay. Let's see if it's working. So it's all version 1 here. Perfect. And now I'm going to do similar, but I'm going to send them to HTTPS to port 443. So there's a tricky thing here. So in plain text, we can specify host header and it will be recognized. In HTTPS, receiving part will not see header because if it comes to wrong host, packet will not be unencrypted. So we need to basically do kind of DNS resolution on sending part, on requesting part. So command is a little bit different, but all we're doing is just doing resolution before a packet reaches HTTPS. Also, I'm using here -k. Instead of -k, I have CA certificates. I could just type CA cert and do. So it basically just validates certificate as valid, but in our tests, it's not really important. And -k makes commands shorter. So you see all requests that going to HTTPS, with header, without header, they landed on V2. So it's desired behavior, and that's what we wanted to see here. Again, there's video, and yeah, if you want to repeat it, follow on your own, so you can follow the video. And how are we doing on time? So it's a last module that we call bonus module, so we can spend some time here, or if we need to move on, we can stop and let people to complete it on their own. Saptak, what do you think? Should we cover one more module or should we continue this presentation?
Yeah, let's do it.
Let's do one more module. Okay, cool. Thank you. So in a lot of enterprise environments, just before I started, because it takes a couple minutes, so let me just initiate it and then I'll explain what exactly. So we'll be creating here NLB. NLB is a different type, so a different type of load balancer. So right now, here I only have classic load balancer, here type classic. Let me just start process and then I'll explain why we're doing it and what we're exactly doing. Okay, just one command. Okay. So what we're adding here, this block different type of load balancer called NLB. A reason for it, in a lot of enterprise organizations, enterprise teams prefer to use it instead of using classic load balancer for multiple reasons. It can be like standards, it can be different CI/CD approaches, but we're seeing it a lot, and especially for internal services reaching one. So here we just want to cover. So we will add this load balancer, and how we will tell traffic where to go. Right now, we will be using DNS resolutions that, as explained before, we using curl commands. So basically, in a curl command, we will specify existing or new. By the way, it's a free, but it's different. It's free B. So it's just to make sure I'm doing it live and so far. So there's we will add this second load balancer. Both of them will work for free. The rest of processing here will be exactly the same. So I added with labels. I didn't add them on previous, but it's exactly the same behavior. So load balancers don't terminate TLS. TLS goes into ingress pod, and ingress pod does TLS termination based on these credentials. So how we will do it? I just initiated command. We're creating service, and in a service, we specify a couple annotations that AWS basically provided that tell this service I wanted to be type load balancer, but I wanted to be an LB. I'll add another, cross-zone load balancer enabled. It's not absolutely necessary, but most of Kubernetes clusters are multi-zone or multi-availability zone in the same region, right? So you have one node in one availability zone and another one in the same region but different zone. So it's, if you don't have any strict security rules about it, it's good to enable it. So it's only two differences. Also, if previous gateway, if you look back to first module we created, it was port 443 and 80. This one is only 443. Protocol is TCP. And what we mean by this, load balancer, please don't terminate my TLS connection. Treat it as TCP. We will take care of it and we will terminate it at the end. So, and if I refresh here right now, so there's a second load balancer, and you see it's type network, my first one. So it's A9, and if I click on it, here, go to listeners, it has this forwarding group. And let's see if it got to a healthy point, because originally when it starts, health checks here, targets. So yeah, both of them healthy. So traffic should be already coming in if it's something. So for some reasons I didn't get to the same screen. I don't know why, but yeah, same idea. So it's healthy. So to confirm functionality, we will try to obtain an IP address, not IP address, FQDN from Kubernetes API. So we call it address NLB instead of just address. So we will have address as a classical balancer and an address NLB as what we just created. Let's see. Compare it again to load balancers. Probably can see it somewhere here on the screen. Yeah, so it's A9CF, right? A9CF. Yeah. So we got right IP. FQDN. So now if we try to send traffic to this, again, if it spend enough time and all FQDN is actually published, we should get a response. Oh yeah, so sorry, I'm also getting address for normal load balancer, so we have it also recorded. So just to compare, so address and LB, right? So we have two of them. And now let's try. So yeah, it's responding and it's sending information as we expected to NLB, and to Hello World version 2, because it's HTTPS, right? So next change we're going to do here, we're going to say no plain text anymore. So I only want HTTPS. So how we will do it? Just changing virtual service. We just remove port 80. So then if request hitting gateway, it doesn't have any information where to go. So caveat here is if you're only accepting HTTPS, and HTTPS in rules going to only to version 2, version 1 will not receive any traffic. We will not be removing it here, and the reason for it, in a lot of enterprise deployments, we actually see that a lot of microservices, they're receiving internal calls. It's not necessarily going through ingress gateway. It may be calls from another microservice in the same namespace or different namespace, but the same cluster, right? So we need to be just extra careful in the real world before removing application. So let's modify virtual service. So I think I just want to make sure right now, before I modify it, I can get response from port 80. So request call for port 80. Yeah, so it's still working. Now, classic load balancer port 443 also working. And now we change virtual service to receive only HTTPS requests, and change should be instant. So yeah, so now not found because request hits ingress gateway, and ingress gateway doesn't have any instructions what to do with this packet. It just response not found. So now only last part, we want to remove classic load balancer, and it's really, really easy. So what we're going to do, we're going to remove service that we created in the beginning. And what will happen, service will trigger AWS to remove this first one. So as soon as I hit delete button, it should disappear here. Service. And refresh. Yeah, so it disappeared right away. So basically now all environment moved from classic to NLB. It can be done without any downtime because you're manipulating your traffic here by DNS records. And it's a final environment we will have here right now. So just to cover a little bit more here. So in summary, which is working for some reason. So what we did here, we took just bare WSL instance of Ubuntu, deployed tools we needed, deployed EKS cluster, subscribed to TID Istio Distribution, installed TID add-on. We looked at both ways to do it, through UI and through command line. Again, we didn't need anything from outside. Everything what we needed for Istio Gateway already packaged with TID add-on. And then did a couple things with Istio to show you power and flexibility of Istio based on header, secure and unsecure traffic using different AWS load balancers. So you can definitely learn more on our classes in Tetrate Academy, and also we offer Istio Certified Administrator certification. That is exam. Who's familiar here? It's kind of similar to Certified Kubernetes Administrator exam, where you take practice tests and assess at the end. Additional resources. So there's two different references for Kubernetes, EKS support for Kubernetes different versions, and also Istio Kubernetes combinations. So if you in the beginning and you're questioning what combination should work for you, please use this resource. Also, all free offerings we have on the marketplace, but again, you can just go on marketplace, type Tetrate, and you will see them. mTLS, we really focused on TLS today, but for mTLS, we have a lot of information. And yeah, if you want to learn more, some additional things is covered in our documentation. And also we have Slack channel. Please come join, ask your questions. Slack channel is monitored by Istio founders, Istio experts, Istio contributors who we work with. So please feel free to use all these resources. And yeah, it's pretty much end of workshop. If you have any questions afterwards, we will be sharing all contact information and you can join us. And I think I'll pass it back to Saptak for a few minutes just to talk about next steps. Okay, I'm now running my applications in Istio and I'm creating multi-cluster environment. How should I approach this? Thank you.
So thank you so much, Peter. One area that I do want to kind of stress on. So we have an enterprise product called TSB, as Peter mentioned, Tetrate Service Bridge. And let me quickly kind of lay out the use cases for Tetrate Service Bridge. So imagine that in any enterprise, you have multiple Istio instances, and with each Istio instance, you'll have obviously the configurations to go along with it. Now, if you are IT or platform team who want to make sure the Istio configurations across your organization is consistent with various levels of granularity. For example, at the organization level, let's say that you want to mandate mTLS across all communications, right? And then there are some areas that you want to give the flexibility to the respective application teams. Now, what does it require? First of all, it requires a management plane which can now program all these Istio control planes. That's what Tetrate Service Bridge provides. It also provides that granular level of permissions, so that the application team only has access to be able to change configurations which impact their applications and not inadvertently kind of disrupting their fellow another team's application, right? So you want to reduce the blast radius to as small as possible without sacrificing their agility. So that's what you want to provide. Thirdly, say there are several use cases where especially in the migration case, right? We have quite a few customers who say today they are on on-prem or on another cloud, and they are migrating to EKS, right? And the migration is never a one-shot thing. Like, it's never like on this particular date we'll just switch everything over to EKS. That doesn't go like that for most complex organizations. It's often a multi-month, if not a multi-year process, where application by application it kind of moves to where to say EKS in this case, where they're migrating to. So in such scenarios, again, you want to make sure you want to keep your configurations consistent, and not just that, you want to also save the headache for the applications team in worrying about the how to configure their applications when it's running on, say, Red Hat OpenShift versus on-prem on some bring your own Kubernetes versus EKS, right? It should be totally be opaque to them where their applications is running. They just need to be able to deploy, and the platform team can decide where it's deploying, which service is deploying where, and it just works. So for this kind of scenarios, Tetrate Service Bridge is perfect, and many of our Fortune 50 customers, specifically in finance, or even customers like Department of Defense, that's why I choose Tetrate Service Bridge. So that's kind of the pitch I had for Tetrate Service Bridge. I think at this point we can take go through the list of questions and see if we haven't answered any of one of those. I've tried to answer the ones that came my way. Let's see.
Also, if we don't have too many questions, we also can do quick demonstration of Tetrate Service Bridge.
Well, that sounds like a great idea. So I think we have about 14 minutes. So we can do a quick demonstration of Tetrate Service Bridge.
Yeah, and please feel free to interrupt if there's a questions and we need to pay attention to.
Sounds good.
So here we have actually environment we used last week for AWS reInvent, and it's enterprise. If I could type, enterprise version of Istio management system, and it has all these attributes. So in this case, I'm entering username and PC or Active Directory. So all of it supported, and permissions can be assigned based on groups. So, and if I look here at clusters, I actually have a lot of clusters here. And you see they have different icons here. So several of them deployed in AWS environment. Also, we have cluster deployed that has different icon here. It's deployed in EKS anywhere. So it doesn't matter where your application is, and I'll show in a second. Communication can be made in any direction based on the rules that your organization enforces, rules and policies. And also we have had OpenShift. So again, it's deployed on AWS infrastructure, but it's a different flavor of Kubernetes. So, and here is more statistics, how many gateways they have, and also we have networks. So networks are used, it's a virtual object, but it's used to actually specify who can talk to whom. It's one of ways to specify these multiple. So you see OpenShift only can talk to tier 1 and transit network. So it cannot talk to any other networks. And transit network can talk to OpenShift anywhere. So if we look here, and let me just uncheck everything, easiest way to uncheck, and look at transit. Select transit, sorry. Let me select it. So, and we have a product called Skywalking that actually builds with diagrams. It's a live data coming from all pods. So every object here has its own has its data collected through proxy. So proxy on every pod is collecting data, and storing it, so we can easily pull it out and see what's going on with different connections. So we can click on any connection and see exactly what is measurements right now, right? So response, network latency, any specific errors, everything we can see here. Also, we can dive in, but before we dive in, I'll just show here as the two clusters, and if I increase it, so these two clusters are EKS clusters, and they're reaching out to OpenShift and EKS Anywhere, but they cannot go directly to a single point that actually stored in another EKS cluster. So always defined by specific rules, how your organization wants your traffic to flow. Also, a tier 1 gateway also does distribution. So you can say, okay, my OpenShift cluster has more capacity than my EKS Anywhere. So I want different percentage of my traffic hit in different endpoints. So and here I can dive in again to metrics and see how my tier 1 gateway is working. And also I can look at configuration for tier 1. And you see it's YAML. It's not Istio YAML, it's TSB, Tetrate YAML that gets translated and converted to Istio for every cluster. And right now I have weight 50 and 50. It means 50% going to OpenShift and Anywhere, but I can switch them in any way we would prefer. Another use case that we kind of seeing quite often here is, so sorry, if there's any questions, I can stop anytime. I'm just kind of covering different scenarios. If there's no question, I continue. So another scenario here is virtual machines. So we have virtual machines deployed using AWS auto-scaling groups. So here with service rating, it's actually served by VM ratings version 5 and by Kubernetes service rating version 1. So how it's done, we auto-scale VMs. It can be 100 VMs and I don't know, one pod, and then traffic gets distributed between them. VMs have Istio proxy installed on them as a binary, right? So it's listening to the same traffic as a pod would be listening to, and decisions are made in terms of ServiceMesh way to send it. But technically it's a part, VM becomes part of ServiceMesh. And again, we can get all data, what's happening with my traffic. So I have very interesting patterns created by traffic generator. So I can see again by version, and version 1 is VM, and version 1 is pod, and version 5 is VM. Yeah, so always available. And again, if I click details, I can see actually what's happening on this VM in terms of error rates and response time and all different statistics. And here I can compare with two. Or I can go to service metrics and specifically pick one and look at specific one. Right? So it's all done on top of Istio. We are not changing, we're using TID, Tetrate Istio Distribution, but we are not, for this management platform, we are not changing how Istio works. What TSB is doing, it's creating manifests in very intelligent way, distributing them to different clusters, and then Istio reads it and configures specific services. Yeah, so I can continue or we can stop here. It's up to audience and other presenters.
Cool. Thank you so much, Peter, Omar.
Thank you.
I think it's a good place to stop. unless there are a few more questions, we'll be happy to take it. Doesn't look like it. I'm just checking the question things if there are any questions which we haven't answered. Doesn't look like it. So yeah, like Peter said, do join us in the Slack channel, where a lot of us hang out and try to help out as best as we can. And of course, go check out the Tetrate Academy. There are some free courses on Envoy and Istio, as well as there are certification opportunities there for that. And of course, if you want to have a deeper conversation with your specific scenario, please feel free to let us know. And you can even email me directly. Just my name, saptak@tetrate.io. Peter is at petr@tetrate.io. So feel free to reach out to us. Looking forward to hearing back from you and getting your feedback. Thank you so much. With that, let me hand it back to Cody.
Awesome. Omar, Saptak, Peter, thank you all so much for joining me today. I know a lot of work goes into putting together these workshops. It's full 90 minutes of presentation and demo, so I know it was no easy feat to put this on. So thank the three of you for all this effort.
Thank you.
Thank you for organizing and hosting us.
Of course.
Thank you.
Thanks for the partnership.
Thank
So
you, Omar.
I'd like to remind our audience that this session was recorded. So following this program, you'll receive a link to access this recording on demand, or you can find it living on the Container Journal website at containerjournal.com/webinars. We do still have those 4 $25 Amazon gift cards to give out. And our winners are Deminda P, Nam N, Arjun B, and Tiago M. So to our 4 winners, please keep an eye on your inbox to claim those gift cards. They should be sent out here in the next day or so. But if you don't happen to see that email, please do check your spam folder. I'd like to thank AWS and Tetrate for sponsoring today's program. And to our audience who's been hanging out with us for the last 90 minutes, thank you for being here. We really appreciate your time. We appreciate your questions, and we also appreciate your feedback. So as soon as we close out, there will be a survey that will pop up on your screen. Please let us know what you liked about today's program, what you'd like to see on future programs, or maybe how we could improve. Otherwise, I do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and Omar, Peter, Saptak, thank you all so much.
Thank you.
Thank you. Bye.